Thanks everyone coming to this presentation. Catherine already told about me. I am an academic at CSU, an agricultural economist. I lead this project assessing the financial impacts of using organic waste as fertilizers. I am the project leader, but this presentation is a collaboration of my team, which I acknowledge. Let me start with the project partners and contributors. Charles Sturt University as a lead, and I have two other colleagues in our team, and University of Southern Queensland, Professor Tech Marsani, and Holbrook Land Care Network. We heard earlier Alison and Nick Macrath, and Soils for Life, James Dare, he's here. And then contributors, DPA New South Wales, we have Anwar, Dr. Anwar, he's our absing expert, and then two other people, they not very directly be involved, but at some stage we will utilize their information. So, I see. Okay. Is it clear? Yeah. Let me start with some of the data. When you look at the fertilizer use in Australia, I first have the table. One has inorganic fertilizer use. You will see over the time from 2000 to 2020 how the total fertilizer amount has changed. You see with respect to different nutrition, nitrogen, phosphorus and potassium, and also you see per capita wise how that changed. Actually the total amount is not reduced. It is more than around 300 tons per hectare. No, 1,000 tons. And per hectare wise there is a reduction. You know that per hectare means over time agriculture land also expands, so land area increase. But you see there is a reduction from 96 to 83, right? So which is due to phosphorus change. You see the three of that. Phosphorus change from 9 to, it has changed from 47 to 30, right? So that may be the reason why the per hectare has been reduced now. And on the other side, you see inorganic fertilizer, organic agriculture, right? Organic agriculture, which we all consider actually, soil carbon, how you use organic matter, right, to improve soil health. And then it has the data there about the share of organic agriculture within the proportion of total agriculture. And then it is increased, but very slowly increased, right? So by 2020, we are having 10% of total agriculture land under organic agriculture. So this is an overview. And the problem here is actually we cannot have either of them, right? Because if you purely rely on inorganic, it is pollutive, it is costly, but it gives you more production. In the organic side, it is healthy, means non-pollutive, less costly, but we will not have more food, right, produce. The problem is we have to produce more food, but at the same time we should look after soil health as well. So we have to be in between. So we should possibly looking the scenario where you can have combination of both of these, right? My next slide is about a framework actually which underpin what we do. It is an abstract manner. I explain from a farmer point of view. You see, farmer's objective is to maximize his profit, subject to, it is a difference of the return he should have, that is priced into yield and minus the cost. You see in that equation I have P is the price of output and Y is the yield, and then I assume everything else equal, so only the cost of the fertilizer and the amount of the inorganic fertilizer, amount of the organic, that is F and C, right? F means inorganic and C for soil organic matter, right? Organic. So that is the simple objective for a farmer, but subject to, when you look at the yield, which should be a function of and the initial soil fertility, that is S, and then inorganic fertilizer, which is F, and then carbon, which is C. And then next year, what will happen? The soil fertility will increase because you use organic, that is S, T plus 1. That is a function of the yield, which is a crop residue, because when you harvest, you leave the residues. And then also the initial soil nutrition, which had ST, and the change, which is the carbon added, right? CT plus 1 minus CT. And then the carbon next year will be actually function of what was initially the soil fertility and the carbon which was added, right? So that is, and then when we look at the organic impact of organic, which is usually long time, right? When we apply any organic, you see it takes time. So you have to look at how a farmer profit would be over time. So we have to do discounting. So we have to see what is the net present value of that profit. So that is a discount factor there. That is a, that 1 plus 1 over 1 plus R into T, the over time, whatever. So that's what you can see, look at where, how long you see. It is depend on what type of organic we use. And then most importantly, when we use organic, it is not only the yield, there are co-benefits. We hear all the time about soil CRC, it is an emphasis on soil carbon. So soil carbon has the role, it makes many changes in the co-benefits, right, which is under the ground. So we may only see the yield, but many things under. So in the next slide, actually I see a illustration. I want to show you an illustration of how the different component here. You see firstly the yield, and then different, I also have to use my glass. Maybe. You see in the diagram here, you can see yield, and then you see improved. When you add organic, there are many benefits, right? So which we regard as a core benefits, right? Improved soil workability, reduce fertilizer use, reduce pesticide use, improved microbial activity, water holding capacity, and then these all have impact, right? Which means reduced fuel use, reduce emissions, and reduce water use, right? And then all have, you see there are trade-offs and offsets, right? So these are the way, after all, we have the impact, right? So which we could see as a financially and environmentally, right? The benefits after all, right? So we know that farmers are using organics in Australia. I saw earlier, I have seen earlier statistics. So we did a survey, actually. It was promoted by our social media through our farmer groups and also Soil CRC. We conducted over 2 times, we revised. So totally there were around 61 response. What we observed there, you see there on average farmers are 6 to 21 years and experience, and the farm size range from 1 to 1,000. So it's a very variation in the size, and then the more major soil types are sandy and clay and loamy. And also the use, we asked about farmers, right? Why they use their land actually. So you could see that grazing with modified pastures and natural vegetation and conservation, and then dry land cropping and see other uses. So I will show you the next slide. What is our crops are there, right? And then there is a significant presence of mixed farming, and then also farmers grow different varieties of same crop, right? Say if it is a wheat, they use different varieties, and then mostly they are very positive to use organic. We ask some of the open-ended questions, and they are very positive, although there are some negative reply of organic use. And then in the survey, I am afraid actually you will not see these small letters, but I can tell you, firstly you see percentage of farmers growing different crops and patches. There are 4 panels of diagram. You see in the left corner that first is wheat, then is oat, then is barley, then is hay, then chickpea, then we see that peas, then broad beans, lentils, canola, then lucerne and pasture. So the most of the farmers are using pasture. So that I mentioned earlier, they are mixed farming, right? And then when you look at the second one on the left side, it is percentage of organic farmers using different organics. So we see that poultry manure, firstly none of the one we listed, then the poultry manure, then pig manure no one responded, and then dairy farm waste, farmyard manure, compost, mulches, biochar, worm use, which is a most farmers use, and then they specify some others, so I cannot group everything here. And then there are inorganic on the other side. When you see your right side, the top one, the first one is none of the anything we asked, then superphosphate, monoammonium phosphate, urea ammonium nitrate, diammonium phosphate. So the main message here is, if you see the last one, on your right side, the last one, the survey indicates more farmers use organic fertilizers, right? Around 75% of the respondents, they use organic, right? Compared to what percentage of them using inorganic is around 40%, which shows some farmers are using only organic and they are also mixed. Yeah. So now given that this information, I will take another 2-3 minutes. Right? So we developed now, knowing this information, we had to analyze some scenarios. So we set up the scenarios. You see that with assumption and what are impact variables. We want to use firstly what the business as usual, what they do, and then when they use organic, the different organic we use actually for our analysis, biochar, farmyard manure, poultry manure, and our assumption is that current situation continue, and the impact variables are which I earlier show in the diagram. Those are the core benefit associate variables, and you can see how much farmers can earn when there is a return, now for example from carbon credit, right, or without. And the next slide, we set up some approach how we have to do that. We choose 3 crops: wheat, canola, and chickpea. Wheat is a cereal, canola is a oil crop, chickpea is a legume, and then 3 type of fertilizers: biochar, farmyard manure, then poultry manure. You see, firstly we will have yield, and there are different scenarios. You see that we increase slightly every of these fertilizer by none of them, then 20, 40 like that. And the right side you see all the core benefits or any other than the yield, right? That is about soil carbon and plant water improvement, nitrogen leaching. So for an example, I have this slide here. I just want to present actually how our work is going. We use ABSIM, and I have here actually impact of farmyard manure on wheat crop in Holbrook. First one, you see the yield change, it improved when you increase the fertilizer rate, and secondly you see how the carbon change, and then the water holding change. So this shows when you use organic, definitely yield improvement and many other improvements. So my last slide is how to use this data. You see that we will generate so much of information, so you can group them under different scenarios. You can group as a what is the impact of soil, what is the impact of climate, likewise. So some group scenarios from the data we could generate. So we do financial analysis. That is, firstly you see profit as a function of price and to the yield, and then cost. There will be many costs here because farmers use these organics, they produce or they purchase. So if they produce, they have material cost, labor cost. If they purchase, then transport. So many of those information we collected through our data. And then we will look at the time-wise, that is the NPW. And also we will use some cost benefit analysis to see change for change. If they add the organic, what is the impact it make in terms of yield and benefits? And then there are also core benefits which we use to see whether farmers can be better off when there is a profit and in top of that. So to conclude, okay, I now conclude. The objective of this project is to see what farmers are doing with organic, right? Their use up, and then what is the financial feasibility, mainly the risk thing. When they use the different combination, they should know actually what combination they can use, right? Which is the yield. And then financially, where they can use it, which ratio they can continue, right? And most importantly, we will develop a tool to guide farmers. So it doesn't mean exactly we are telling every farmer for what they do, but we will develop some approach which will give them some knowledge, inside knowledge, which will inform them how they can optimize their use of organic, right? Actually, currently now we are doing our testing with APSIM, and I am also looking the economic data we collected from survey to conduct financial analysis. Thank you very much.